Hello fellow friends. Today we're going to talk about the binary search algorithm. Now it is the very basic algorithm which you will find in any of your data structure and algorithm course. So first we'll talk about why we need binary search. Before studying binary search, you might be familiar with linear search. So what linear search look like is like you have given an array. Let's suppose this is an array given some elements in it, and you are supposedly going to find an element in it. It might be at the last, in the middle, or at the first. And let's say suppose in terms of time that for searching or for looking out an element in a array, you take 1 second time. So 1 second for each element to traverse. So if this element is at the middle of the array, let's suppose this array size is 100, so it takes 50 seconds to go on to that element and check that element linearly. And if it's at the rightmost part of the array, you will have to take 100 seconds. Now this is a very big time in terms of the program which we will see. As you can see, our programs are quite fast, and this 100-second times, which is more than 1 minute, is a very bad thing to have. So here comes the binary search at the rescue. So binary search is a divide and conquer algorithm technique. So what divide and conquer algorithm is, you can relate it to your history lessons which you have taken in your 8th class. The Britishers used to just divide us and conquer the kingdoms they succeed. So if you want us to make a separate video for it, hit it in the comment section. So for n elements in a linear search, we are taking n seconds to search for an element if it is at the rightmost part of the array. So but take my words, if you are using the binary search, this would be log of n. So if you are taking 100 seconds for searching the rightmost element in the linear search, you will take only 7 seconds. And if you are not understanding what these terms are, the order of and the worst case time complexity, we will be making a separate video for it. So let's just see some condition of the binary search. So the basic condition and the most important condition of the binary search is that the array must be sorted. It might be like in the increasing order or in the decreasing order, but it should be sorted. Means the array should not look like this. Now this is an unsorted list, so we'll not use it. So first, if this comes into our input, so we'll first sort it. So let's just sort this first. So the 2 comes first, then 4, then 7, then 13. Let's just take it as 14. So 14 and then 46. So this is a good array which we'll use for the binary search. So what binary searches look like? Let's suppose we have given an array with indexing starting from 0. So 1 is stored at index 0, 14 is stored at index 2, 31 is stored at index 6. So this is a basic representation of an array. So how binary searches look like? So you can just correlate it with the type of the searching you do with the book. So if you are trying to you are going to go to a page number which is 343 in a 1000 page book, what do? You just flip the book into 2 halves, you go to the 500 page and see whether this number lies in the first part, which is the 1 to 500, or in the second part of the book, which is the 500 to 1000. So you know that it is in the 1 to 500. So you ignore 5 to 1000 part of the book. You just then again split into 2 halves, which is 1 to 250 and the 250 to 500. So you can just see that you can just again compare that the 343 do not this page number do not lie over here. So you can just ignore this and proceed to search over these pages. So this is the basic algorithm or basic insight what we do in the binary search. So let's just see how this applies to this array. So let's see what binary search algorithm looks like. So let's given this is an array and we are supposedly searching for an element. Let's suppose 20. It's a good number. So we are searching for the element which is 20. It is given at the index 4. So I have previously told you that it is basically related to divide and conquer algorithm. So what divide and conquer says, you can just understand from the word also that it is divide and then we have to conquer. So let's just divide the array. What in the divide we do? We just divide the array into 2 parts. So what is the middle point of the array? So yes, the middle point of the array is 18. Yes, you can intuitively see that it is 3 from the rightmost element and 3 it is 3 from the leftmost element and 3 from the rightmost element. So let's suppose we are searching for the element 20. So we'll compare it with our middle point. As we can see that the 20 is bigger than 18, and we have been thinking that if it is greater than 20, and we know previously that this array is sorted, so we can say with confidence that this element, which is 20, would not lie in the left part of the array. Yes, so our searching part for the left part of the array would be nullified. So we'll not search for this part of the array now, because we know that 20 would not lie in the left part of the array. So what we do, we search in the right part of the array. So this is an array after the dividing step. So what we do now, we search for the middle point again. So what is the middle point now? It is 25. Yes, it is the 25 element. So we then again compare 20 with the 25. We can see that the 25 is bigger than 20. So we can say from our intuition that this element is this array is sorted, that this 20 would lie in the left part of the array, which is having 25 as its middle element. So what we do, we ignore the right part. So voila, we find the 20. So this is the basic algorithm of binary search. So let's just see what would be the case if the number of elements in an array is even. So let us now see for the case when the number of elements in an array are even. So here it is, the number of elements in this array are 8, starting from index 0 ending at index 7. So let us suppose that we are going to find an element, we are going for searching an element, and let's suppose we are going to searching for the element which is 13. So it is over here. So from the previous example, we know we have to divide the array. So let's just see a different type of technique which you can use to divide the array. So we can see from here that the number of elements over here are even. So the question comes into your mind that how are we going to divide the array? So the basic formula which you're going to use is this. Mid, which is the middle element or the center element, is equal to the left element plus right element by 2. What this left and right represent? This left represent the basically the array or the subpart of the array we are seeing, and this is the leftmost element or the leftmost index of that array. And for the right, this is basically the rightmost element or the rightmost index of that array. So keeping aside this formula, keep in mind that we are going to use this formula only. So let's just implement that formula over here. So what is left over here? Yes, it is 0. What is right over here? Yes, it is 7. We are talking about the index, guys. So that is divided by 2. And let's just say we are using the floor. So what the index come? Yes, it is 3. So we are going to go to the 3 and search whether 13 is bigger than that or smaller than that. And we can see that 13 is smaller than 21. So we can confidently say that this element, the 13 element, would not lie in the rightmost part of the array. Why? Because we know that this array is sorted, and we can save our computation while searching this part of the array. So what we can do? We'll ignore that, create a separate array with some same indexing or different. We know the formula, guys, right? Which was left plus right by 2. What is left over here, right? 0. And what is right? 2. We are talking about the index. So divide by 2, that is 1. So here the middle point is 1. Voila, we found it in the 2 steps. So this is basically the position of the 13. So this is basically the binary search algorithm. It is very easy to implement and very fast to work if you given an sorted element. You can just implement it with using the binary tree also. And we are going to make a separate video for binary tree in the further episodes. Knowledge from this video, please do consider like, and if you just love this video, please do consider subscribe. Thank you for watching.